Talking about algebraic proofs, and in order to do an algebraic proof, we need to be able to talk about the outline and what it looks like. And so here we can see on the left-hand side that these numbers are kind of out of order. And the reason that those are out of order is because when we fill them in for the actual proof, this is where we'd fill those in. So the first thing that we look for when we are doing a proof is we want to see what was given. And we usually write that in the first line or the first couple lines of the proof. The next thing that we want to look at is we want to say, what are we trying to prove? And even though it usually goes 1, 2, 3, we put the 2 at the bottom because the prove, we can't prove it until we've gone through the steps to get there. So part of the steps include the diagram. So we want to get a great diagram to illustrate what's happening there. Then we can also talk about, we got to make statements. And then those statements, there has to be reasons why we can make them. Can't just go around making statements without any reason why we're doing that. So that's the general outline, and then we'll do a couple examples. Something that might come in handy is this foldable. So we have the addition property of equality, and underneath it we have a formal definition using if-then statement with variables. And then we also have on the back side, we have examples of what that might look like when we are solving. So the first thing that we want to do is we want to go back to our steps, and the first part that was said is find the given. So the given, we are given this equation here. So I'm going to write this down as 5 times y minus 3 plus 12 is equal to 6y plus 20. Now, these are all different reasons right here that we could include over here on the right-hand side. So this is our statement where we stated this equation. And the reason that we can say this is because it was given. So that's the reason. Now, the last thing we're trying to say is prove y equals negative 23. And so that will be down here at the bottom. In this case, we don't have a diagram, but our diagram will be our work as we're going through the process. So there's a number of things that we can do always to solve this. What I'm going to do first is I'm going to distribute. That's going to be my reason. Or, yeah, that will be my reason. So the first thing I did was distribute. So 5 times y is 5y. 5 times negative 3 is negative 15. Plus 12 is equal to 6y plus 20. And the reason I was able to do that is the distributive property of equality. And we can abbreviate like that, distributive property of equality. Okay. There's another of different steps that we can do. And one that's not on here is combine like terms. So here we have a negative 15 and a positive 12. So what we're going to do there is we are going to just combine like terms. And that's going to give us 5y minus 3 is equal to 6y plus 20. And the reason we can do that is combine like terms. All right, so we got 1, 2, 3 more steps. So I have to kind of combine lines a little bit. The next thing that we can do is we can add 3 to both sides. And so I'm going to add 3 here, and I'm going to add 3 here. And the reason that we can do that, I'll write it right on this line after we get done. The 3's cancel, and we're left with 5y is equal to 6y plus 23. And the reason that we can do that is we did addition, property of equality. Now we want to get our y's together, and what we can do is we can subtract 6y from both sides. And then what we're left with over here is negative 1y is equal to 23. And the reason that we could do that is we subtracted both sides by negative 6y, or by 6y. So that was subtraction. Property of equality. Getting close. The last thing we want to do is we want to see how we can get rid of that negative 1. And in this case, we can divide both sides by negative 1. And that will give us y is equal to negative 23. And the reason we're able to do that is the division property of equality. And then, so that was what we were trying to prove. So we got it. And when we get done, there's a couple things way we can finish. We can finish with different ways that we can finish our proof. We could say 3 dots. We could say a box shaded in, or we could use QED. And those are different ways that we could say, I have proven what I set out to prove, and now I'm done. So right here, I finished my proof, and now I'm going to say QED. My proof is over. So we take a look back real quick. In this case, we didn't have part of it, but the first thing that we had was we wanted to find our given. So that was 1. Then we needed to prove what it was asking us to prove. So here's step 2. Step 3, we didn't have a diagram, but for step 3, that was going to be our work for these. That's going to illustrate what we're actually doing. And then step 4 is all of our statements, and step 5 is the reasons that we can make those statements.